Last week, attackers compromised the npm account of the lead maintainer of Axios. If you're not familiar, Axios is an HTTP client library that JavaScript developers use to make API calls against service endpoints. I'm a huge fan of it. It's a great library. It gets pulled like a couple 100 million times a week from npm. Within 39 minutes, they published 2 backdoored versions. Every machine that ran npm install during those 2 hours got a remote access trojan or a rat, and that includes Windows, Macs, and Linux. There was zero malicious code in Axios itself. The attacker actually injected a hidden dependency that did the damage. After it ran, it deleted itself and then replaced its own package.json with a clean version. If you were compromised, there was no obvious trace left on your machine. The Axios project had a modern publishing workflow through GitHub Actions using OpenID Connect, or OIDC, which is the recommended way of publishing to npm. A secure path existed, but a long-lived npm access token was still sitting alongside it, and npm allows you to create access tokens that bypass two-factor authentication. The attacker grabbed the old token, published directly to npm, and bypassed the entire pipeline. To be clear, the maintainer had 2FA enabled. He did the right things. This was a structural problem and not one based around negligence. A secure path existed. It just wasn't the only path. npm is having quite a year. Like Shai Hulud in September, Shai Hulud 2, the second coming in November, and yes, the attackers actually called it that. The Chalk compromise, Trivy, and now Axios. So as a developer, we naturally ask ourselves, what can we do about this? Check your package.json files. If you're using the caret symbol in your dependency versions, that little hat symbol, you're telling npm, install this version or anything newer that's backwards compatible. That sounds reasonable until actually someone publishes a backdoored patch and your next install pulls it down automatically, and that's what happened here. Pin your versions to exact numbers, and in CI, use npm CI, not npm install. npm CI respects your lock file exactly. It won't silently upgrade anything. If your lock file doesn't match, it fails, and that's what you want. Disable post-install scripts. The entire attack ran through a post-install hook in the hidden dependency. Scripts don't run, malware doesn't execute. Also, feel free to add an ignore scripts equals true to your npm RC file. PNPM does this by default now. There's another feature you can use, which is the minimum release age. It's basically like a cooldown. Your package manager won't install anything published less than a set number of days ago. If someone publishes a malicious version at, say, midnight and it gets caught and then pulled within a few hours, your builds actually never see it. It's like a safety fuse between the publication and your pipeline. npm, PNPM, Bun, UV, they all support this. I honestly thought that SolarWinds would be the wake-up call for our industry around this. That was back in 2020, and here we are 6 years later watching the same class of attack play out every few months, except now they're self-replicating, deleting their own traces, and hitting packages with a couple 100 million weekly downloads. The software supply chain will always be an attack vector, and that's not changing. What can change is how you consume packages. So pin your versions, verify packages, set a safety fuse. That's the part you can control. I'm going to be making more of these videos going forward and share with you my take on how to ship software. If that's useful to you, feel free to subscribe and like this video if you found something useful. I'll see you in the next one.